So now let's talk about RAG and knowledge bases. So what is RAG? RAG is Retrieval-Augmented Generation. Behind this very fancy name, there's a very simple concept. This allows your foundation model to reference a data source from outside of its training data without being fine-tuned. So how does that work? So we have a knowledge base and it's being built and managed by Amazon Bedrock. For this, it must rely on a data source, for example, Amazon S3. So your data is going to be in Amazon S3, and then automatically Bedrock is going to do some magic. We'll see how that works exactly, but it's going to build a knowledge base. And then a user is going to ask a question to your foundation model saying, who is the product manager for John? So that's probably something related to his company. And of course, the foundation model does not know anything about John because John is a very specific query for my company and my own data. So there's going to be something called a search, and this information is going to be searched in the knowledge base automatically. Of course, this is all happening behind the scene. But this knowledge base is backed by something called a vector database. And to create the data in the vector database, again, Bedrock takes care of everything. It's called creating vector embeddings. And I will show you how that works later on. But basically, thanks to this vector database, then we're able to retrieve the relevant information out of this knowledge base. And for example, we get some text back from this saying that we have some information about John, such as we have some support contacts. We have a product manager, which is Jesse Smith. We have an engineer, which is Sarah Ronald. And so all this is going to go as an augmented prompt. And so it's going to be the original query as well as the text that has been retrieved that are going to be passed together into the actual foundation model. And the foundation model is going to look at this augmented prompt and generate a response saying, hey, it looks like Jesse Smith is the product manager for John. And it's why it's called retrieval-augmented generation. Retrieval because we retrieve the data outside of the foundation model. And it's augmented generation because we augment the prompt with that external data that has been retrieved. So hence the name RAG. And so RAG in AWS, Amazon Bedrock, is going to be a knowledge base. So this is very helpful when you need to have data that needs to be fed and that is very up to date, that is in real time, and that needs to be fed into the foundation model. So how does that work? Well, here we have an example. Give me talking points for benefits of air travel. As you can see, one of these talking points has a little one on it and a link to airtravel.pdf, and that PDF may be in Amazon S3. So this is an example where the RAG and the knowledge base has been used to give an answer to a specific prompt. So everything needs to go into a vector database. And so we have several options. So vector databases on AWS and Amazon Bedrock can be of several kinds. So we have two services on AWS that are possible to use as your vector database. The first one is called OpenSearch Service, and the second one is called Amazon Aurora. So remember the names, Amazon OpenSearch Service or Amazon Aurora. And we have three other options, and maybe there'll be more in the future, of course, but we have three other options right now to use for a vector database. We have MongoDB, Redis, or Pinecone. And so you can configure a knowledge database backed by any kind of these vector databases. But if you don't specify anything, AWS is going to create for you an OpenSearch Service serverless database for you. So next, we need to have what's called an embeddings model. And this is how to convert the data into these vectors. And so it could be Amazon Titan or Cohere. And it doesn't matter if you don't use these models as your foundation model, the embeddings model and the foundation model can be different. So your S3 documents are going to be chunked. And that means they're going to be split into different parts. And these parts are going to be fed into the embeddings model, which is going to generate vectors and place these vectors in the vector database. And the outcome is that now these vectors are easily searchable. And so when RAG will look into the vector database, it will find the right passage in the right document to be able to augment the query. So the exam may ask you to choose the right RAG vector database, at least from a high level. So you don't need to be expert at databases. I'm going to give you more information that you need to figure out database, but The first categories I would say would be Amazon Open Source Service and Amazon Document DB. So Open Source Service is a search and analytics database, and it's very good. It's going to be definitely the preferred choices, and you're going to have real-time similarity queries, and you can store millions of vector embeddings. The other one that's really high performance is Amazon Document DB with MongoDB compatibility, which is a NoSQL database. And again, you get the real-time similarity queries and store million of vector embeddings. So I would keep these ones together. Then we have Amazon Aurora and Amazon RDS for PostgreSQL. So both of them are going to be relational databases. Aurora is proprietary on AWS, but it's cloud friendly. And RDS for PostgreSQL is a relational database as well, but it's open source. Both are fine. Usually, if you see relational database, think one of these two. And finally, if you see graph database, choose Neptune. So I don't think there's going to be any question asking you to choose between the 5 databases together, but definitely you'll see a question about choosing our relational database for a vector database, and you may have to choose Aura or RDS for PostgreSQL. Or if you see something around high performance and real-time similarity queries and million of vectors embeddings, is going to be Open Source Service or Document DB. Or if you see Graph, Neptune. That's about it. I don't want to go too deep into these databases, but this should be enough for the exam for you to get going. So what kind of data sources can we use in Amazon Bedrock? Well, we have Amazon S3, which is a place where you can put a lot of files in a cloud directory, Confluence, Microsoft SharePoint, Salesforce, as well as web pages. So it could be your website, it could be your social media feed, etc., etc. So anything in the web. And I'm pretty sure that Amazon Bedrock will add more sources over time. But from an exam perspective, I think remembering Amazon S3 and maybe these ones should be enough. And of course, if from an exam perspective, you need to know about more data sources, I will of course include it in this slide. So what are the use cases now for Amazon Bedrock? Well, you can build a customer service chatbot where the knowledge base is going to be your products, your features, your specifications, troubleshooting guides, and frequently asked questions. And so therefore, your RAG application can be the chatbot that will answer customer queries and look up in this knowledge base. It could be for legal research and analysis, where the knowledge base is going to be laws and regulations, case precedents, legal opinions, and expert analysis. And this time we can have a chatbot that is going to have relevant information anytime we have a specific legal query. And we can have also a healthcare question answering. So again, the knowledge base can be diseases, treatments, clinical guidelines, research papers, and previous patient data. And the application could be a chatbot that will answer complex medical queries. So RAG opens up a lot of possibilities for doing GenAI on AWS. So I hope you liked it, and I will see you in the next lecture.